Yes, ma'am. So I think I must be audible right now. If there are some glitches, technical glitches, please be patient. Meanwhile, I'll sort it out within a minute or two. So let's begin our today's presentation and lab session. Okay, so under this capacity building program that is on blockchain technology and application, we are going to learn today some concepts on private data in Hyperledger Fabric, and there will be we'll be doing some experiments on uh, how to create a private data collection in a Hyperledger Fabric network, and then we will be doing something more that is based on secured asset transfer. So yesterday's lab, I think most of you have installed, like yes or no. So how many of you have installed Hyperledger Fabric in your machine? You're ready with your machine today? Anyone? Can you write in the chat if you're ready with your Hyperledger Fabric network running in your system, or some like Docker is running as well as Linux is running? So, okay, if it is not there, we'll hope that in the future you'll do that, and then you'll be able to do some experiments on that. Okay, so incomplete. Shyam Deshmukh says that he has this thing incomplete. Okay, so I think our videos that is live streamed is actually saved in the YouTube, so you can directly go there and then you can find it out how to install. And there are certain things that are needed, but for every system, we cannot create a video. So it is a generalized video, and if you are having some more problems, so you can find it the solutions either in the Stack Overflow or something. Some blogs are there that will help you in coming out of that problem. But still, if you are not able to do that, please write us. We will help you. Okay. So for today's session, we'll start with some presentation. That is, let us understand what is private data first, and then we will be able to do some secured asset transfer using private data. Okay. So using private data in Fabric. So all these contents that I am showing you right now are taken from this Hyperledger Fabric read docs. So these things are readily available. So you need not like don't bother about that where these contents are taken from. So they are available, readily available, and they are being updated every time. So whenever there will be a new version of Hyperledger Fabric, so they'll be giving you read docs related to that version. So right now I've taken 2.2 version because yesterday I've told you that we have installed 2.2, and we'll see that what is private data and how we can use that private data. So this tutorial is actually focusing on the private data collection to provide storage and retrieval of private data. So what is private data? So any data that you want to make secure, that nobody else should, whomsoever is authorized, only those people can see that data, can use that data. But other than those people, it should not be made available like to those people who are not authorized. So here when we will talk about when we are having Hyperledger Fabric. So in blockchain network, no one is the person actually. So everybody is peer. So when we'll talk about a peer or a node, just think about when we were doing some Solidity coding on Solidity smart contracts. So there were nodes, and whenever we'll talk about Hyperledger Fabric, there will be peers. Okay, so an organization can have many peers. Okay, so there will be some authorized peers from that organization who can actually perform a particular task. So an organization can divide a task into many peers. So task means they have a single peer for a particular purpose. So there should be a purpose. Okay, so for that purpose there can be a peer or more than one peer. Okay, So, a private data is something that we make actually to, there is something that we don't want to disclose to everyone. Okay. Right from the starting of Hyperledger Fabric, when we'll come upon like when you will go into the history of this Hyperledger Fabric. So, in the earlier versions of Hyperledger Fabric, there was no concept of private data. So instead, what people were used to do is actually they used to like suppose there are two organizations. Okay, so suppose I want to share some data between these two peers. Suppose there is a peer of organization. This is organization one, and this is organization two. Okay, so you want to share some data. So instead of the administrator used to divide the data like this subset of data, like this is the data is D, the subset is D1, and so only D1 he wants to share with the other organization. So this D1, for this D1 a separate channel is created. So suppose there are like, because data, if we are talking about data in a Hyperledger Fabric network, and an organization is a big organization, so there can be a thousands of tuples and thousands of attributes in a database. So suppose you want to have this data to be shared, this not to be shared. So their administrator has to make multiple channels. Okay, for each data, like this should be shared, this should not be shared. So for because channel is having the capability that only the authorized people can join that channel, and only those people will be able to see whatever is inside the ledger related to that channel. So in that case, in that particular case, you have to create more than one channels. Okay, so to get rid of this problem, because this is the overhead for an administrator to have multiple channels. Okay, so this creates overhead, and this led to the development of private data. Okay, so instead of creating multiple channels, we are going to define the private data, and we are going to define the policy whether this private data will be able this particular organization will be able to see this private data or not. This particular peer also from that organization can see this data or not. So this is what was the view from their side. Okay. So what is private data? I have already explained you. So that I have already told you that the creating separate channels in each of these cases, like if you want to keep a data private from other organization, so one should create a new channel for particular data. So however, creating channels in each of these cases create a additional administrative overhead. So that I have already discussed it with you. So instead of doing that, we are going to create the private data collections. Okay. Now there are two types of things. Two elements are there. Okay. So the actual private data, the data we can read. Okay, we can see, and the hash of that data. So anybody can tell me that what is the hash of a data? If you'll be able to understand what is hash, then like I'm asking you about something related to cryptography. Actually, blockchain is very, if you know cryptography, then you'll be able to understand many things in blockchain. Otherwise you'll be able to understand some partial, like sparse things you'll be able to do. So anybody can tell me in the chat that what is crypto? I'm waiting. What is cryptography? What is hash actually? What is hash? Nobody? What is hash? Is it the private key? No, we cannot say it like this. So hash function, no hash function. I'm asking about what is hash. Okay. So consider a data actually. So suppose there's some data. Okay, this is some data. There are certain, yeah, transforming. Yeah, exactly. So yeah. So Dr. Kumar has said very correct thing. So what is hash? So suppose you are having a data like this, you are doing some algorithmic computation on this data, and now you are converting it to another domain. This data is converted to another domain. So by applying some hash algorithm, what will happen? You will not be able to get it back. Like suppose if some reverse procedure, reverse computation is performed, you'll not be able to generate that thing. Okay. So this is hash. Hash is actually we cannot convert it back to the original data. So non-reversible thing, kind of thing. So, but one thing is sure in case of hash, that if a particular data is if D1 data is there, if it is producing hash of H1, then if we change this data and this becomes D1 dash, okay, so there will be a different hash for that. Okay, so H2 will be created. So for a particular data, there will be a unique hash, and this is done with the help of SHA, popularly that is known as secured hash algorithm. Okay, so using SHA, you can generate a hash of a particular data, and then that hash represents that data such that if you change that data, that hash value will not be created. There will be a different hash value. So what happens? Suppose we are converting. Suppose there is there is some intruder that is coming into the network. Okay, and that intruder changes some data, and you want to see whether that data has changed or not. So you can apply hash, and then you can save that hash. If there comes an intruder and he changes the data or she changes the data, and if you will compute the hash on the same data, you'll have a different value. So you'll find the difference. If there is a difference between these two values, then you will come to know that yes, there is some discrepancy or there is some change in the data, and you can report it. Okay. So in a collection, in a private data collection, there are two things, two elements. First one is actual private data, and the second one is hash of that data. So the actual private data is sent peer to peer using a gossip protocol. So there's a protocol that is defined in Hyperledger Fabric, that is a gossip protocol, and using this protocol, we are sending data peer to peer. Okay, so one peer is actually sending the data to another peer, but only the authorized one. So this data is stored in the private state database. So this is very important thing. This is private state database that is actually needed with each of the organizations. Okay. So each organization will have their private state database, and inside the database, we are having the private data. So there is a separate database. So there are you can think of two types of database, that one is for public and one is private. So this data is stored on the peers actually of authorized organizations. Okay. So those, suppose I want to share this private database to other people. So what I will do is I'll authorize some organization, like I know that organization 3 is good, organization 7. I want to have communication with these two organizations. So what I will do is I will authorize those organizations, and then I will share this private state database with other people whom I'm authorizing. So no need to create another channel for that. Okay, so same contract, same chain code API, same everything will be same. Only the difference will be there, that only the authorized people will be able to see the data, that is private data, and the data which is not private, that is public, will be able that can be seen from the other unauthorized peers also. Okay. So what is hash? Okay. So why hash actually? So hash is there. Suppose there is a fight between two organizations, that no, we have agreed on that particular thing, and then now you have changed the private state database. So what happens is that if you are going to change in your database, suppose organization 1 is there. This is organization 1. Let me clear this. So, yeah. So suppose there is one organization. Okay. This organization is actually having some private data, private state database. Okay. And suppose for a particular product, like for mobile phone, they have quoted like it costs near about 1,20,000. Okay. Now with other organization, it has shared that yes, mobile price is 1,20,000. Okay. Now when they have done agreement on that particular thing, that yeah, I'm going to transfer this asset to you. Suppose that organization has something fishy in his nature, in its nature. So what he will do is he will, although give the consent that yes, I'll sell it to you 1,20,000, and he will change this database to 1,40,000. Now when this organization will come to this particular thing, this organization for NFT, that please give me that mobile phone, please transfer that details. So it will say that no, it is now 1,40,000. So what happens is, for 120 there will be hash value, and for 140 there will be a different hash value. So this hash value, for that agreement, this hash value should be h, and now if it is changed, it should be h des. So it, now this organization can claim that no, whenever there will be audit or some kind of some authority is there, who is going to, you know, uh, who is going to check whether what is the issue between these two organizations. So that organization will, that particular authority will check the hash value, and then they will be able to resolve that yes, organization 1 was incorrect and the actual value was actually 1,20,000. So this is what hash will help in in endorsement actually, and this hash serves as evidence of the transaction and is used to for state validation. Okay, so these two things are very important when you are talking about private data collection. So you got it? Can we move forward? Everybody there? Okay. So there is authorized peer and there is unauthorized peer. So this diagram will help you in understanding what I'm talking about. So there is a channel state database and there is a private state. So channel state database has something to do like that is actually visible to all the peers for that channel. Okay, so there can be peers, but there can be authorized and unauthorized peer in the same channel. Okay, so private data is K1 and secret value is K2. So what is stored in the channel state is hash of these two things. Okay, so if this is this value is hashed, then if K1 is changed, the hash value will be changed. So this will help in actually uh, finding out what is the change in these two networks. And if there is a change, then there's they can claim that yeah, so this value has been changed and this is incorrect. Now let us understand this use case. So suppose there is a group of 5 organizations on a channel who trade and who trade produce. Okay, so there is a farmer who is selling his goods abroad. Okay, there is a distributor, so he'll be helping the farmer in moving the goods. There will be a shipper who will help distributor to ship those goods, whatever farmer and distributor are having. There will be a wholesaler who will be purchasing the goods from the distributor, and there is a retailer from the wholesaler who will buy these things. So all these entities are connected to each other. So suppose there is a blockchain network, a private blockchain network. Suppose they are using a hyperledger fabric based network. So there'll be certain things like a farmer will share with distributor but not with shipper. So a farmer does not want to disclose the things to a distributor, but wants to disclose things to a distributor but not with shipper. A distributor can have some certain things that he may allow to read by a farmer, but distributor doesn't, we needs to disclose with shipper, or something with shipper but not with farmer. So there can be cases when all these entities want to share something with each other, but not with like another person. So just think about these kind of situations where you want to share something, you want to make something private to a particular organization or a particular peer, but you not want to share this thing to another peer. So in this case, we'll have a private data relationship. Okay. So the private data relationship is actually okay. I have not pasted the diagram, so I'll tell you. Yes. So this is something that I was talking about. So suppose there is a distributor. So there is a private data collection with farmer. So shipper organization and sorry, distributor, shipper and farmer are actually having some private data collection PDC1. So the name of that data collection is one, and they want to share something that is actually readable by these three organizations. There is some different thing like organization related to distributor. He wants to share something with wholesaler, but not with shipper and farmer. So distributor wants to share something to wholesaler, but not with farmer and shipper. So they then distributor will create a new data collection. Here, wholesaler will share something to shipper and retailer. Okay, and this all these three things are related to only single channel. So they have not created a different channel, but the same channel they have utilized, and they have kept something private, and that is actually there will be a policy, and they will keep this policy with each other, whatever is they want to share or not. Okay, so this is what we were talking about, the private data collection. So let us begin with the begin with the exercise, or we can say begin with the this practical thing. So can we begin, everybody? Are you there? Say yes or no in the chat. Okay, okay, good. Yeah. So it seems to be very good if you respond. So there's some connection between whom the lecture is delivered, whom the lecture is delivered, and the deliver who is giving the delivery. So yeah. So let us go to this. Okay, we'll go to the Hyperledger fabric. So it is creating some mesh. So let me close all these. Okay. So we are done with this presentation. Let us begin. Yeah. So you just need to go to this page, that is Hyperledger fabric page, first page. So I'm sharing it in the chat. So you can directly click on that and come to this page. Okay. So after you'll be in page, you have to click on this build your first network. So I'm going to build our first network. No, because I just want to reach to the tutorial section. So that is why I've used that link. So yesterday we have created our first network. Okay. So in this under this section, there is some tutorials that you can maximize. Okay. So there is a tutorial section where you can find a number of tutorials, but you need to be there with the release 2.2. So this is very first thing that you should be there. So I'm giving you the link of this release 2.2. Yeah. Okay. So release 2.2. Now we have seen how to run the fabric test network. Now, we have seen in that test network that we were having containers running. There are two organizations. Now, then we have created channel yesterday. Then we have started a chain code where there was a asset transfer basic chain code. This asset transfer basic chain code that was written in Golang. Then we have interacted with the network by calling some functions like get all assets, and then we have changed some asset. So the owner, we have changed it, like we have changed it to from something Michael to Christopher, and then we have seen it with the help of automation 2 details. Okay. So this we have seen yesterday, that there is some chain code, there is a channel on which the chain code is deployed, and there is a communication between the two organizations who are ready to join that channel. Okay. Now we'll come upon this using private data in Fabric. This tutorial I'm talking about. Yeah. So let me come to this thing. Yeah. So I've sent you the link, and you can open that link. So if you are in this page, please let me know yes or no. If you are in this page, like private data, you can write in the chat private data. I'm waiting for everyone. Please write private data. Yes. Okay. Yeah. Good. So I've got 3 responses. Okay. So let us start. Okay. So this tutorial will demonstrate the use of private data collection to provide storage and retrieval of private data. So we will be using asset transfer. Yesterday we have seen this asset transfer basic chain code, actually uh, the smart contract. Okay. So that same use case we will see. What else we will do is, in this tutorial, is actually we will build a collection definition in a JSON file. Okay. So there will be a JSON file that will have some collection details. Okay. So what is the collection, that whatever we want to make something private, there are certain things that we need to have in the collection, like specified that what should be the policy. There is a purging rule, purging kind of thing. So we want to have certain data for a particular amount of time. Then we want to remove that data. So all these things are actually specified in the JSON file. Reading and writing private data using chain code API. So we will be using certain functions that will help in writing private data and reading the private data. So that is what is important right now in this tutorial, that we have to not only read the public data, but we are able, if we are authorized, then we are able to read the data and write the data. And if we are not authorized, then we cannot read that data and write that. And then we can deploy that particular contract that has all these things like private data collection. We'll have a private data, and we will deploy that contract. We will register the entities, like we will be able to authorize some entities that yeah, you are authorized and you are not authorized. Then we will be creating an asset in the private data. So first we have built a collection, like we have specified the structure. Okay. And then we are giving the value to that structure, so creating an asset. Then we will be querying the private data as an authorized and authorized peer, and then we will be able to transfer the asset. Purge the private data means we will be removing the private data if it is not like if it is not required anymore. Okay. And these two things are additional sources, so we'll do that till the purging of private data. Okay. So let us understand what is the use case. Okay, so there are two organizations. Okay, so organization one and organization two. So organization one have a private collection, and organization two will have a private data collection. Okay, so MSP is actually membership service provider. Okay, so organization one MSP is a peer who will allow to create a private data collection. Okay, so membership service provider will help you to authorize a peer or not. It will help in giving you particular rights if you can be there or not. So a member of organization one will create a new data set, and that organization, the member will be referred to as owner. Okay. So there will be certain details that are related to the public details. So there will be some public details and there will be some private details. Okay. So the public details of that asset are referred. They're taken as identities and identity of the owner, and the public details are stored in the data collection, private data collection, or in private data collection also they are stored, but as we have seen in the last diagram, that there's some hash value. So we'll be storing some hash value on the public data set, public details. Okay. So there is one thing that is related to asset is the appraised value. Okay. So that appraised value is actually we are bothered about that should be kept private. So due to this appraised value, we are going to create a private data collection. So this appraised value has created the problem for manager, like that manager of that organization, that yes, this appraised value should not be kept public for everyone. So that is why a manager of that organization has given you the solution that yes, you have to use the private data collection. Okay. So initial appraised value is agreed by the owner. So owner who will be creating this private data collection will initialize that appraised value. Like suppose I was talking to you about a phone, a mobile phone. So initial values was 1,20,000. So this appraised value should be kept private, and then it should be initialized by the owner of that particular organization. Now, to purchase the asset, so there should be someone who wants to purchase, because the person who will purchase this asset, then we will transfer this asset to that person after he purchases it. So to purchase the asset, buyer will be here. The organization two will be the buyer. Okay. So buyer needs to agree the same price value. Okay. So both the organization are agreeing on the same price value. There can be a situation where suppose there's some kind of bluffing, like organization two wants to purchase, then after that he agrees, and then he's not going to purchase. Like he's saying that no, I wanted to I have agreed on something value lower than what you have specified. So there should be some agreement, like on the same appraised value, so that no other organization, like no not in the part of organization one or not in the part of organization two, both of them cannot deny for the same appraised value. So there should be a appraised value, and there should be agreement, and this agreement is actually recorded as a transaction. Okay. So this value is stored in the organization. Yes. So in this step, the buyer, who is the organization two, creates an agreement to trade and agree to the appraised value, and there will be a contract, a smart contract function, agree to transfer. And this agreed value, because owner is organization one, so this organization one can change that value. So that agreed value should also be made available to organization two, so that if organization one changes, organization two will can claim that no, that was not the thing. So this is what is actually in the value in both the organization's private data collection. Now this is the collection definition that we are going to create in a JSON file. So this is very important thing, like name of the collection. So we'll name it, like every channel has its name. So we are going to name a collection. So there should be a name for the collection. There is a policy, like peers allowed to process the collection data, like the peers who will be able to have that collection in their state database. Okay. Now the required peer count. So number of peers to disseminate, like how many peers from my organization will be able to pass this private data collection to other peers. So number of peers required to disseminate, like they will be able to pass, they spread this thing to other peers. Okay. Max peer count, like suppose there is a, because these peers are going to disseminate the private data, so other peers will be able to copy that data in their ledger. So so the number of other peers that the current endorsing will attempt to distribute the data. So how many peers I'll be able to give, like suppose I'm giving this value to 10 people. So this 10 is the max peer count. Okay. Block to live is very important thing. So think about a situation when whatever we are making a particular data as private, we want to have that personal information for a very limited amount of time. That is very sensitive. Okay, we need not have that value. Like suppose a defense organization in our country is going to deal with some other organization in another country. Okay, but after they agree and they want that this deal is there, but we don't want this private data to be there in the network uh, for more than a particular amount of time. So for that defense data that is very sensitive, we can have a block to live field that will allow that for how many number of blocks in that particular channel, because every block there'll be in every block there'll be a number of transactions. So for how many number of blocks this data should persist. Okay, so if we are giving it 10,000, 100,000 blocks, so after 100,000 blocks, this data will actually this will get deleted. This will get purged. And if block to live field is given as 0, it means that it should be there forever. So block to live field 0 shows that you need not the you don't need to purge that private data. Okay. Member only read, like if this is the policy that is made true, that only the members of that organization can read that value, and member only write is only the members of that particular organization are able to write, like make the changes. Okay, and there's endorsement policy, like how many people will be able to, like suppose there are 10 organizations, so we are going to have 51% people to endorse that policy, whatever endorsement policy we will need. So it depends on us that whatever endorsement policy we get. So there are ample endorsement policies that are available, so you can read in with this link. You can go to there and you can have endorsement policies. Okay, so you can read that. Coming back to the private data. So here, what is written in the current tutorial? For this current tutorial, so there are three collections. Okay, so asset collection, then this organization 1 MSP private collection, and organization 2 MSP private collection. So there are two different collections, like for each organization, and there will be an asset collection. I'll tell you what is there. So here you can see that this is common for all, like our policy will be there. Okay. Here, when organization 1 is defining its private collection, only organization 1 is responsible for that. No other organization should be able to, like claim for that database, or they should not be able to make changes to that data set. So the policy is only organization 1 member can make changes, can read that data set. Okay, and read that data set. So member only can have that data collection. Then member only read is there. So member only read is true. Member only write is false. Okay. So member only can write is false. Okay. Here the same thing is for organization 2, and the signature policy is only here you can see that only policies for only member 2, sorry, only organization 2 member, and here is only organization 1 member. So rest of the things are same, like block to live field is 3. So until 3 blocks, up till three blocks, this data will persist, and then data will be deleted. But for this asset collection, not the private collection, this asset collection, block to live field is 100,000 or like 1,000. Yeah. So this is the policy. Now, how the contract is created here? So there is a structure that we have already discussed yesterday, that the structure belongs to a particular asset, and that asset has fields of, like what is the type, and what is the ID of that asset, what is the color of that asset, what is the size of that asset, and who is the owner of that asset. But here you can see that what is the private data. So can anybody tell me, after reading this, whatever I'm displaying you in the screen, can anybody tell me that what is the private thing related to that asset is kept? So what is kept as private? Anyone? I think you might, if you are with your mobile phone, so there is some problem while writing the answers, but the people who are with their systems, they can give us answers. So anyone who will be able to tell me what is the private details that we have kept? It is written over there. So the private details, should I wait or continue? Okay. So the private details here are is actually appraised value. This appraised value is the private details. Okay. So there are three things. First thing is asset collection. Second is organization one MSP and organization two MSP. So one and two will have these details, private details. And the first one that should not be kept private, they agree for that it should not be kept private, is asset collection, and then that asset collection is actually this asset structure. Okay, so now we'll proceed. So all of the data, this is very important line, that all of the data that is created by the asset transfer private data sample contract is stored in PDC, private data collection. All these things are stored in the private data collection. Okay. So here you can see, this is the very good example, this diagram that shows you that what we mean. So organization one peer is there and organization two peer is there. So there are three things: public state, private state. Okay. And here public state, private state. Okay. So there are two private states. Okay. So in one of the private state, there is asset collection, ID, color, size, and owner. No appraised value here. And then there is another collection uh, for appraised value. Here also same. So there is OR policy, and then they can read these things. Okay, each other's private state. But here they cannot change anything. Okay, they cannot change anything. So there are two types of functions that are given in the contract, that is read asset and read private details. Okay. So read asset details, we can read asset ID, color, size, and owner. But by using read asset private details is appraised value. Okay. Now, second thing is writing the private data. So for writing the private data, there is a put private data function that is given in the API. Okay. And API is actually the smart contract. Okay. So no need to confuse related to that thing. Okay. So write the private data using the collection named asset collection. Okay. And write the private data appraised value. Since there are two things, there are two states. So one is for this and one other one is for this. So for writing this, we need to have two separate things. So twice we have to do is writing asset collection and writing to the private data collection. Okay. So suppose I'm going to change something. So to maintain the integrity of that particular data, if I'm changing, so I need to change that in other organizations private collection. Okay. So suppose we are acting as organization 2. So we want to change the appraised value. So we would replace the organization 1 private collection with the organization 2 MSP collection. Like we have changed something, and then we have to like copy paste kind of thing. From we have to replace the organization 1. If I'm organization 2 and I've changed something, so I need to replace this thing. And if you are replacing something in organization 1 private collection, that need to be endorsed. Without endorsement, you cannot change. So if it is endorsed, means both the organization are agreeing to do that. Okay. So this is this contract that is there are the functions. Create asset function is there. Then there are certain conditions. Like verify these are the conditions. So yeah, okay. So this is the function. Yeah. So there are certain conditions that should be met before we are going to create the asset. Okay. It will take too much time to discuss about all these things. So So let us again check that we will be having a collections config file. Collection config file is only for defining whatever there will be a private data collection and data collection is there. And there are two private data. So one is related to asset ID, color, size, and owner. Then other one is actually the appraised value. Okay, and like the data will be with the same data will be with organization one MSP collection. Okay, so what we will be doing, we'll be starting the network first. Then we will be deploying the private data smart contract to the channel as we have done yesterday. But this is private data. So asset transfer basic we have done yesterday. There is a new contract that has this function for creating a asset, and that has two types of structures. So this private details is structure. Okay, so that is different to the earlier one in the yesterday's class what we have studied. So let us do that. So what we will be doing, we will be deploying the contract to the channel. Then we will register the entities because we have to authorize the organizations, peers of those organizations. Then we will be creating the private data using that JSON file, and then we will be querying the private data as an authorized peer. So if I'm authorized, I'll be able to read that asset and I should get the output. Okay, so this is the output. Like this has read the asset one, so this should be the output. And if I'm using, I want to read that private data without being authorized, like I'm unauthorized peer. So there should be an error. Like uh, I'll not be able to read the private data. Okay, and then we will be able to transfer the set. Suppose organization one and two agrees on some uh, for transfer of certain asset, like organization two buys something from organization one, so that is we will be transferring the asset. Okay, and then we'll purge the private data, like we need not to have that data anymore, so that is sensitive data. So that's all will be for today's on this that is practical session on this private data. Okay, so let us start. Okay, so I must open Ubuntu. Yes, it is here. Docker should be running. Let us see images are there or not. Yes, images are there. So I think let us check Ubuntu is connected. Resources. Yes, it is enabled. Okay, so I'm doing that. Okay, so first we have to go into the fabric samples. So let us do that. Okay. Hmm. Okay. So first we have to go to the fabric samples. And the test network. Okay, so we are inside the folder. So let me clear the screen. Okay, so here they are saying that first you have to put down this network if there is any container that is running that is of no use, that might create the problem. So network dot sh and then down. So we'll down the network. Okay, so there are no such things that are running. Okay, now the second thing is we will be using single command. Yesterday, what we were doing, we were making bringing up this network first. Then we have created the channel separately, and then we have deployed the chain code. Okay. So in the same command here, we are going to up the network. Then we are going to create the channel, and we are having a certification authority, and the state database is CouchDB here. So we need, because there's a private data collection that should be stored. So we need that this database. So CouchDB we will be using. So either LevelDB or CouchDB may be used with collections, but here CouchDB is shown. Okay, so there are certain advantages that CouchDB also supports indexes. So how to use those indexes, but we are not going to cover this in today's session. You can read it by your own. So let us do that. So okay, where is my kernel? This is my kernel. Okay. So you can see over here, there are, yesterday we were having only 3 peers that were running, one for each, one peer each for the two organizations, and only one peer for ordering. Okay. Okay. So we can check it out like using Docker ps minus a. So we can see over here that there are certain peers. Okay, let me. This is very big font size. Okay, yeah. So here you can see that there are certain peers that are running, each for a different purpose. Like there are two CouchDB, and there are two certification authorities. There is one orderer, and there are two peer organizations. So there'll be one CouchDB container running for organization one, another for organization two, certification authority for organization one, certification authority for organization two, and there will be one orderer who will be able to order, or who will give the ordering services. Okay. Now, uh, so where were we? Yeah, here. So we have done this thing. We have created a channel, and then we have some containers running. Okay. Now we have to deploy the private data smart contract. Okay. So this is a different smart contract. So as in the last class, I have told you that, yeah. So what is the chain code name? What is chain code package? Or chain code language is Go. Chain code endorsement policy is that EP is for endorsement policy. So this is our endorsement policy. Okay. Then there is a path for that, and there's a configuration. CG is for configuration file. Where is the configuration file for that? So we are specifying certain things, and now let us run this command. So whatever is required for the goal and more packages are required. So it is going to download. Everything is specified in that JSON file. It is saying that code is now packaged. Okay. So the file is actually private tar.gz. So that is the file name in which the packaging of that chain code has been done. So chain code packaging is actually nothing but suppose there are I want to change something in the chain code. So packaging will allow that you cannot whatever is deployed you cannot change it. If you want to change it, then you need a different deployment for that chain code. So after packaging of that chain code, it is agreed like yes, these are the things that are whatever are specified is actually we agree upon. Now it is installing. So but first it is packaged and now it is getting installed. So waiting for the installation. These examples actually will help you when you are going to develop a organization level like a big application where you are giving some solution to an organization. So these small exercises will help you. We will give you an idea that how you can solve that problem and how you can do some solution, how can you can perform some thing. And there are since these tutorials are actually error free, they are capable of running all those things. So whatever, suppose you are missing something in your JSON file, so you'll be able to see, you will be able to correct your JSON file by referring to this one that is available inside the tutorial. So this is very important thing, and this is very good thing that is given by the Hyperledger people. Okay. So here you can see that they have also tested that yeah, chain code definition committed and query chain code definition successful. And what is the name of that channel is my channel. So on my channel, the chain code is deployed. So now chain code is running. Okay. And let us uh, do other tasks. So yeah. So this one. Now, when both the organizations approve the chain code, we have seen that both the organizations have approved this chain code definition. Okay, so approved by both the organizations, yeah, like organization 2 and organization 1 and organization 2. So if they have approved, now using peer chain code lifecycle chain code approved for my organization command, the chain code definition include the path to the private data collection definition. So I will make I'll approve that private data collection for my organization. Okay, so that there will be a copy of that private data collection in my organization's private database. Okay, so here you can see, you can read it out like approve for my organization. I'm 7050 right now. Then order TLS is there. The JSON file, that is configuration file. Signature policy is all, and sequence one sequence one means this is very first chain code. If you are going to change the chain code, then the sequence may change. It can be a different chain code. Okay, so sequence one is the first version of that chain code that right now I'm using. I have not changed that chain code. Okay, certification authority file is already given. So order C means this the environment variable order C will be checked. So copy and then we have to paste it. Let us see. It is saying that no, peer command is not available. So peer is not available. It is not able to see the peer because we have not changed the uh, environment variable. So let us go back and see. So yeah, so where I am right now. Let us see where I am right now, and then I'm going to change the environment variable. So right now I'm in the test network. So let us go back to the Hyperledger test network. We are going. So using Fabric test network. So here you can see that there were certain commands for peer. Yeah. So you have to uh, this you have to export this path. Okay. So although examples, the tutorials are good, but there are certain things they they left, like they have not given you, so they have missed actually. So and second thing is that Fabric CFG path. Okay, now let us test if peer is working or not, because we have given the path to the bin folder. Let us see if it doesn't works. Yeah. Oh, so let us come back to this thing. So let us check it out. What is the problem behind? Okay, it is giving us this we have done. Here lifecycle chain code we have done. Hmm, this we have done. Here lifecycle it is not working. Okay, let us do this thing. Error. Okay, the TLS root certificate files. Okay, so there's some problem with TLS root certificate files. So let us go back. Mm, okay, let us do that. Okay. Now let us see if they have specified that which organization we are right now. So, start the network. We have to be organization one. Okay. So deploy the network. Note that it has a private. Okay, let us do that thing. So we have set the path. Now we are going to run that command. Uh, yes, order CA. No, it is not working. Why it is not working? So this is 2.1. Let us see whatever is missing in 2.2. Yeah, they have missed this thing. Anybody who is able to run this thing? Uh, Let me go back to 2.2. Yeah. So deploy we have done. CA file. Okay, CA file is actually okay. I don't know what is the problem. Hmm. Yes. Uh, okay, let us do it in another system, or if it is showing me another error, then Then we'll start with the different tutorial. I'm very sorry. Okay, so let me. Okay, so we were here in the chat. Let me see. So we were in this tutorial. Okay, so let me open my Ubuntu first. We were here in this tutorial. So first, what we have to do is we have to start the network. Okay, so I think Docker must be running. So I have to make my Docker desktop running. Okay, let us see the images, whatever images. Yeah, so they are there. Let me open it Ubuntu once again. Ubuntu. Okay, let us do one thing. First command we have to run. Okay. So channel is up. Then we are going to deploy the chain code. Okay, so we need to we now use the test network. Okay, yeah, this network. I think you must be doing. How many of you are doing with me? Is there anyone who is doing this thing with me? So, is there any issue from your side that is coming in your window? Okay. So here you can see that actually we don't need not run these two commands. I was running, but that is why it was showing some errors. So we have to start it from here, register entities. Okay. So we'll do that. Let us wait for the chain code to be installed and for period 0 of organization 2 also. Okay. So we are waiting and then we'll do that. I'm very sorry. So meanwhile, it is getting installed. Let us discuss. Okay. So after the deployment of this chain code in the channel, we will be registering the entities. So the private data transfer, these smart contracts, they are, it supports ownership by individual entities. So individual entities can have ownership. Like there is no combined ownership of two entities. Okay. So the owner of the asset will be member of organization one. So there'll be like 7051 and 9051. There are two organizations you can see in the GitHub. So sorry, in the Docker. Okay. So here organization one and organization two will be there, where organization one will be the owner of the asset and organization two will be the buyer of that asset. Okay. So here, what we will do, we will first become one organization, and then we'll do certain tasks, and then we'll be doing something with the organization too. Okay. So let us do that. Yeah. So now what we will do is we have done with this thing, which command network. Okay. Okay. Yeah. So now we'll become organization one. Okay. So Fabric CA is certification authority. Okay. So first we'll become organization one. We will authorize some organization, some peer in our organization. Now you can we have what we have done till now. We have set the path for Fabric CA client, and here we will be organization one, and then now we are registering a new owner client. Okay. So Fabric CA client tool. So the PEM file is required here. This certification certificate, it has the certificates. This PEM file is it is different for every individual. Like if you are doing, it is different for you. So here you can see that TLS is enabled, and then the password is owner PW. So there is something that we have registered a new owner client. Okay. Now, you can now generate the identity certificates and MSP folder by providing enrollment name and secret. Secret was, this is the secret. Okay. So let us do that. So we are going to enroll this particular organization as what? So the secret is owner PW, and the name will be owner. So there are two things. Okay. So we will be registering. Yeah. So we have made one of the peers as the authorized peer. Okay. Now run the following command to copy the node. Okay. So we have to copy this thing. Don't bother about these two commands because there's nothing to tell you more. Now, so being organization one, what we have done with these commands is we have set the path to the organization one. Then we have a certification authority that we have told that yes, this will be the certification authority. That certification authority have authorized one peer of organization 1 to read the private data collection. Okay, this is all. Now we are becoming as organization 2. We are now doing something with organization 2. So there are two options. Either we can open a separate terminal and do that, or we can do this with this terminal only. So we can now use the organization 2CA to create the buyer identity. Okay, so let us do that. So same thing, buyer password and buyer. So the name is buyer and the secret is buyer password. Again, for organization 2, we have done, and this is what we have done. Now the most important thing is create an asset. We have to create an asset. Okay. So now that we have created the identity of the asset owner was organization 1. So we can invoke the private, that smart contract, to create a new asset. So here, uh, until now, none of the functions, none of the actually API of that chain code was called. Now we are going to create the asset and then we are going to sell or buy that asset. Okay. So first thing is we have to become a organization, that is organization 1. If you wherever you see 7051, it will be organization 1. So let us become organization 1, and then we have to create the asset. So export asset properties, run the following command to create the asset. So we have to create this asset, export asset properties. So we are creating the asset. So asset ID is asset 1, color is green, size is 20. Okay. And then when we will be invoking the chain code. Okay. So here you can see the asset properties variable we are creating right now. This is the variable. Asset properties is the variable where we are going to create an asset that has color green, size 20, and appraised value 100. And now using these properties, we are invoking the chain code and passing these asset properties. So these asset properties are passed, and these are passed, and an asset will be created. So both these commands we are running right now. Yeah, one and the same thing. Okay. So this is invoked. It is invoked and the query is successful. Now we are going to query the private data. Since we have created an asset, so what was that asset? The asset was ID was 1, color was green, and appraised value was 200. So we will see. So this we have done till now. Now uh, query the private data as an authorized peer. So we are going to query it. So peer chain code query is the actual command, chain code query command, and it will not create any of the transactions. We are just querying that. So asset 1, because I am the organization 1 peer, authorized peer, so I will be able to read this asset 1. Yes, so it is giving you that yes, asset 1 is green, size is 20, owner is this. So owner will be identified with X509 certificate. Okay. So you will not be able to understand all these things because uh, you have to read all these X509 certificate properties. Okay. If you already know, then it will be very clear for you. So yes, it has given us a asset. Now we are reading the private details. Okay. So what are the private details? What is the private detail is actually the appraised value. So let us read the private details. So appraised value is 100. That is the private thing. Okay. Private thing means that is sensitive data in case of sensitive data. Now, if I'll become, because this is the asset that is created by organization 1, and if I'm the organization 2 and I'm going to read that asset. So let us become organization 2 and then read the asset as an unauthorized, because I'm not authorized right now. Organization 1 has not allowed me to read that, see that asset, because that is unauthorized. So let us query that chain code for that asset. So this will work because this particular detail, these details like for asset one, color and all that will be available. But if we are going to read the that sensitive data like the appraised value, so that will not be allowed. So let us check. Let us check. So yes, becoming organization 2, because we have become organization 2 and then we are checking the asset. Now I am going to read the private data collection. Okay, so I'm going to read the this private data collection. Yes. So it is giving nothing. Like I'm not getting any. I'm not allowed to read that collection, so I'm getting nothing. So if I'm the user from uh, uh, organization 2, I'll not be able to read that private data. Okay. Now, nor can a user from. So they're saying that if you are an organization 2 peer, you cannot read that thing. Okay. And like I'm not like if I'm organization 2, I will not be able to read the organization 1 values, and if I'm the organization 1, I cannot read the private collection of organization 2 in both the cases. Okay. Now I'm going to transfer the asset. Okay. So here there comes the hash value. So let us see. So uh, because I'm organization 2, I'm reading organization 1. So endorsement failure query, because we are not allowed to read. And transaction ID it returns, but this hash will tell you that no, you cannot. This hash will tell you that you have tried to read, but that was failed. Okay. Now transfer of the asset. Now what I'm doing right now is we have to become again organization 1, and then uh, so we have to become organization 1, and then we have to check it out. Uh, uh, we have to transfer the asset to a particular person. So here, before transferring the asset, we have to agree for that appraised value. So to transfer the asset, we need there should be an agreement with the between the buyer and the seller. Okay. So who is the owner is organization 1, and organization 2 will be the buyer. So they should agree upon the appraised value. So asset value is actually 100, appraised value is 100, and then there should be there should be agree to transfer like function on this appraised value. Okay. So agree to transfer function is called uh, I'm the organization 2, and I'm happy to take to buy that asset. So it is saying yes on this asset value. I am because we have read that asset value. So yes, I'm able. I'm right now. I can buy that thing. So buyer says that I can buy that for 100, and then I can check that what is in the private collection. So let me copy that thing. So appraised value is 100. So earlier the asset value was 100 that I wanted to buy, and the appraised value is actually 100. So both the values are same. Now because organization 2 has agreed to buy, now organization 1 will be able to like export it. It will be able to give you like send you that asset for that appraised value. Okay, so let me become organization 1 again, and then I will transfer that asset to organization 2. Okay, so agree to transfer. We will check that whether organization 2 is, yes. So buyer, it is, this information is about the buyer that who wants to buy this thing. So the buyer is organization 2. Here you can see ca.organization2.example.com. So this organization 2 is ready to buy this asset on a particular value. Okay. So organization 1 has checked. Okay. And now the asset owner will be changed. Okay. So asset owner will be organization 2 MSP. So because I am right now the owner of asset 1, that is organization 1, now I am giving the rights to organization 2 to who can have now because they have agreed on that appraised value, then organization 2 will be able to. So yes, so now the owner will be organization 2. So let us query that whether who is the uh, owner of that asset 1. So here you can see that asset 1 has the, now the owner is actually organization 2. Okay, so buyer was organization 2. Now what we have to do now, if we have given that asset to another organization, so now we can remove that data from our private data collection. So let me check. We have to do, you can confirm the transfer, remove the, so read first we have to read the asset details and then we can remove it. So let us purge the data. So for purging the data, uh, suppose I am organization 2 and then I want to remove all this data. So first we will see that there is asset 1 in my organization 2's data collection, and then we are going, this is asset 1 that is already there. Now after purging, that will not be there. So let us do that. So these are the asset properties. There are 2 or 3 assets, and they are saying that here. This is a very good thing that they have given. Here they are creating 3 new assets. Okay. So for every asset, there will be a block created. So since in the when you have seen during this this JSON file, they have specified, yes. So they have specified block to live field as 3. So if there is asset 1, and if we will create 3 more assets, then this 3 field will tell me that the very first asset, because 3 has come, 3 new assets have come, so a very first asset should be deleted. Okay. So here they are saying that if I'm organization 2 and I'm creating 3 new assets, like these are the 3 new assets. Here you can see that asset 2, asset 3, and asset 4. 3 new assets are created. So if these 3 are created, then the asset 1 will automatically get deleted due to the purging rule, like block to live field, due to this block to live field. So let us see. We are creating 3 new assets. Okay. So first asset, second asset, and the third asset. Yes, this is second asset and this third asset. So after creation of these 3 assets, where we will query for the first asset. Okay. So we will query for the first asset. Asset 1, there will be no asset. We will not be getting any of the details because it has been purged. See, you will not be having any details. Suppose I am going to check asset 2. So it is saying yes, asset 2 is appraised value with 100. But if I am going to check asset 1, then it is not there due to purging rule. And suppose I am going to create a fifth asset. Let us create one more asset, fifth asset. Suppose this is the command, and let us create the fifth asset. Okay, so uh, okay, first we have to copy this thing. Export asset properties. This one, first one, this, and let us do this thing on the notepad. And I'm copying this, and now I'm changing it to asset 5. So asset 5 color is yellow, and value is suppose 500. Asset 5 is created. Okay, size we will take it as 15. So let us see in this command. So okay, copy, then we have to paste it there. Yeah, so we have created another asset, asset 5, and since 5 is third to second, so second asset will be deleted. Okay, so we have to create, we just have specified this asset, but we have to create this asset. So let us do that. This command we have to copy, and then we have to run this command. So yes, chain code query is successful. Now we will read asset 2. That was earlier we were able to see that thing. So let us check. It is saying asset 2. Yeah, okay. Let us do it again. Like asset 5 is getting created. So asset 5, asset properties, then let us do this thing. Okay, let us see. Again, we are creating asset, one more asset, asset 5. Let us check for asset 5. It says it already exists. So yes, so okay, likewise you can do that because we are running short of time. Asset 6. Let us create asset 6. Yeah, and then let us create asset 6, and then yeah, and then let us check for asset 3. So asset 3, if it exists or not. It exists. Okay, so there's some problem. Let us check for asset 2 if it exists or not. No, it doesn't exist. So after creating asset 5, asset 2 doesn't exist. After creating asset 6, like asset 6, asset 2 does not exist. So if we'll create 7, then 3 will be deleted, and likewise. So this is how purging happens when we are in this. So now, because it was in between, we have to move from one system to another. So we have completed right now this whole private data fabric. Now we will we have to we'll see that what is how we can do secured asset transfer. Okay. So again, let me go back. Then /network sh, and then we have to down this network. So secured asset transfer. So you have seen that I've told you that there is something known as hash. Okay. So while we are doing secured asset transfer, um, because we in this scenario, like in the last one, we have seen that we have been transferring one asset from one of the organization to another organization. Here security is maintained with the help of like in the earlier example there was privacy, like there was we were making the data as private and only authorized peers were there. And here we are adding one more security to the transfer. Like we are, if we are going to transfer something from an organization to another organization, then we will be using something that is known as salt actually in this. Okay. So this all we have seen like right now in this where we were using this private private data collection. So they are saying that if you want to transfer one asset from an owner to someone that is who is buyer, so how the privacy is maintained. So the smart contract uses the following techniques to ensure the asset properties to remain private. Okay. So what is that? So the asset metadata properties, like who is the organization. Metadata means data about data. So data about asset actually. So who is the owner of that asset? Like one more at one more level. Okay. So there is for every asset there is a hash value. Okay, and that hash value is stored on the chain. Okay. So whenever we want to make this private properties to be like to get secured, like in like there are some intruder who is who can generate a same kind of hash for a different like suppose there is a dictionary attack. So I'm doing something uh, uh, on the hash value, like I'm taking out the hash because hash value is public to all. So I'm taking out that hash value and I'm trying uh, just like this. Let me use some annotation. So suppose for this x value, so h of x is y. Okay, is y. Now suppose I'm going to take this y and I'm going to reverse doing something reverse of this y and producing x. Okay, so as I've told you that is irreversible, but in case of dictionary attack, I will guess what should be the y. What should be the y here? I will guess using a dictionary. So there will be a dictionary from where I will take one y value and produce x. Okay, for some y value, we will produce x. For some y value, we will produce x. So inverse we are doing. So here, to save our system more, like to make our system safer, secured asset transfer. They have given a very good example of secured asset transfer where we are going to use a salt value. So I'll tell you later. Okay, same scenario is there where there is a buyer and we are going to create a private asset and that and for that private that for that asset there will be a private data collection and then we are going to transfer that asset and then we are going to purge. Okay, so same agreeing to transfer means here we have seen that organization 2 has agreed to buy that asset for a particular appraised value. Okay, and then because we have seen that organization organization 2 has agreed on for that particular value, then organization 1 is going to send that asset. Here, when you will read that, so the asset owner is there and asset buyer is there who have agreed to buy that asset and then transfer that asset. Okay. So the agreed price is secret for each other's members. Okay. Here, we have two things: a price and hash of each price. Okay. So uh, if organization one has a price and it has generated a hash for that price, organization 2 also will generate a hash for the same price. Okay. And if the price is same, the hash will be same. Okay. Now here there is something, they have added a random trade ID to the price agreement. Okay, so to make this transfer secure, they have agreed to add random trade ID that only these two organizations know, like organization 1 and 2 know. So that will be termed as salt value. So they have added some salt to that value, and then they will then there will be a transfer of that asset. So due to that salt value, nobody like who is the intruder will be able to guess the price. And rest of these things are very quite similar in both the context. Like if there is a so let us check. So we first have to deploy this network. There will be a contract that is asset transfer secure agreement. Okay. So then we will be organization 1, and there will be organization 2. So they are saying that we will open two different terminals, one for organization 1 and other for organization 2. Then we will be creating the asset. Okay, so from organization 1 terminal, because both the terminals will be there, so from organization 1 terminal we will be doing these things, like we will be creating an asset, then we will be transferring, we will be giving some value to that asset and all that. Here you can see that whenever we will be creating the asset, there is private in the private properties of asset, there is one more value, that is salt value. This is the salt value that will be associated with that asset. So using that sort value, we have created one more step of computation for the intruder to guess and to like to get into it, like to hamper this thing. So this salt value will help us to make the asset more secured, and there will be a secured transfer between these two organizations. So I think you can do it by your own by reading all these commands, and these they are already they have already given you the information that why you are doing this thing, and then you will be able to sell that asset being an organization 1, and then you will be able to buy that asset using organization 2. So same set of commands, only one more thing that is added is the salt value to the asset. So doing it once again will not be meaningful, like, but still this is the thing that needs to be told to you, that yes, there is one more thing, that is salt value to make the asset transfer secure. So I'm done from my side. Thank you so much, everyone, for being so patient in this session. And I'm very sorry that in the middle of the session there was something that error was coming, so we were able to resolve that. Thank you.
Thank you, Samir. Participants, if you still have some questions, you can definitely raise your hands or ask on chat. Yeah, it was a nice session indeed, although I could not attend the full session. There are no questions, then let us have a photo session. Request you all to please put on your videos so that we can have a session. We can have a photo session. Thank you so very much, all of you, for thank you. Thank you all. Neha, Durgesh, please take the screenshot. Thank you once again. So tomorrow we will be starting at 10. So request you all to please join before 10, because sometimes it so happens that the speaker is also, today's speaker was, Dr. Suel was having certain problems, but then.
Yes, ma'am. Mr. Kishore has raised hand.
There is a level of uncertainty, but if you join on time, we can start at 10 tomorrow. So with that, I wish you a very good day. Please enjoy your time with your family and friends. If you are on holiday or enjoy your work, we'll be meeting tomorrow morning, 10 a.m. Thank you so